to form an integral and stable rock zone around the gallery. We often utilize anchor rods to work with surrounding rocks to maintain the stability of the gallery. What kind of member the anchor rod is, and what is its function in tunnel engineering? Now, let's learn about its mystery. An anchor rod is a rod-shaped member made of metal or other materials with high tensile properties. It is one of the important means to maintain surrounding rock stability and ensure construction safety during tunnel construction. Anchor rods commonly used in tunnel engineering projects are grouted anchor rods. It usually consists of the rod body of the anchor rod, the mortar between the anchor rod and the rock mass, the base plate and the nut. How does the tunnel anchor rod act on surrounding rocks to maintain their stability? According to the different attitudes and stabilities of the stratums of surrounding rocks, the effect of the anchor rod mainly includes the following 4 aspects. First of all, the anchor rod can constrain the deformation of the surrounding rocks and exert pressure on surrounding rocks to maintain surrounding rocks near the chamber surface in biaxial stress state, in triaxial stress state, preventing surrounding rock strength from deteriorating, which supports surrounding rocks. Secondly, the anchor rod is very effective for reinforcing the rock mass with developed joints and the loose areas of surrounding rocks, helping fractured rock mass and loose areas to form a whole, and becoming a reinforcement belt that can reinforce surrounding rocks. In addition, for horizontal or gently inclined layered surrounding rocks, the anchor rod group can connect several layers of strata together and increase interlayer frictional resistance. From the perspective of structural mechanics, a composite beam is formed. It can improve the interlayer frictional resistance to form a composite beam. Finally, anchor rods can prevent individual unstable rocks from falling or sliding, and connect the stable surrounding rocks with anchor rods. The effect mainly results from the reinforcement of locally unstable rock mass. After knowing the effects of anchor rods, how should we arrange the anchor rod during tunnel construction? In fact, anchor rods of different surrounding rock environments should be arranged in different manners. First of all, for the fractured surrounding rocks and the tensile failure area of the crown, we can arrange anchor rods locally and focus on reinforcing the unstable area, which can save materials and stabilize surrounding rocks. Secondly, in the broken weak surrounding rocks, we need to arrange anchor rods systematically to provide overall reinforcement. Anchor rods should be arranged perpendicular to peripheral contour. However, for strata with inclined layers, as the instability is mainly caused by the slide along the bedding plane, anchor rods should be oblique to the bedding plane. Finally, we need to determine the length and row spacing of anchor rods, which are the main parameters that must be determined. In anchor rod engineering design, generally, the length shall be determined before the spacing. According to the provisions of Code for Shotcrete Bolt Construction Method of Railway Tunnel in China, design of the length of anchor rods by NATM, for good rocks, the length of the anchor rod is generally 1.2 m. For slightly poor rocks, the length of the anchor rod is generally 2.3 m. For broken rocks, the length of the anchor rod is generally 4.6 m. For expansive strata, the length of the anchor rod is generally 4.6 m. Design of the row spacing of anchor rods by NATM. For good rocks, the spacing between anchor rods is generally 1.5 m. For slightly poor rocks, the spacing between anchor rods is generally 1.5 m. For broken rocks, the spacing between anchor rods is 0.81 m. For expansive strata, the spacing between anchor rods is 0.81 m. After knowing the arrangement of anchor rods, how do we carry out anchor rod construction? Let's take the construction of mortar anchor rods as an example. First, select materials and determine the mortar mix ratio. The anchor rod body should be made of HRB 335 and HRB 400 ribbed reinforcements, with a rod diameter of not less than 22 millimeters. It shall be straight, free of rust and grease before use. For cement, ordinary Portland cement with a cement strength grade of not less than grade 32.5 shall be adopted. For sand, medium fine sand with a particle size not greater than 2.5 millimeters should be adopted. The accelerator shall be subject to rapid hardening effect test before use. Generally, the initial setting duration shall not be more than 5 minutes. Mortar mix ratio. The strength grade of cement mortar shall not be lower than M20. Drilling shall be carried out after material selection and mortar mix ratio determination. The hole position, spacing, intersection angle with rock surface, hole depth and hole diameter of drill rod shall be determined as per the anchor rod support design. Drilling shall be carried out with rock drill. Generally speaking, the intersection angle between the anchor rod and the rock surface, bedding plane or fissure surface should be 90 degrees. The hole diameter shall be 15-20 mm greater than the diameter of the anchor rod, to ensure that a certain quantity of mortar is filled between the anchor rod and the hole wall. Grouting and anchor rod installation shall be carried out after drilling. Before grouting, the grouting pipe shall be inserted to 50-100 mm from the hole bottom. During grouting, the grouting pipe shall be slowly pulled out. When the grouting pipe orifice is 20-30 cm from the hole mouth, grouting shall be stopped. After that, the anchor rod shall be inserted to the hole bottom to fill the hole with mortar. Next, install the base plate. Anchor rods must be installed with a base plate that shall be closely attached to the concrete surface. The base plate is generally made of 610 mm steel plate, with a specification of 150 mm by 150 mm or 200 mm by 200 mm. Finally, carry out quality inspection on anchor rods. The scope of quality inspection on anchor rods includes the length, spacing, angle, direction, pull-out resistance, etc. of anchor rods. Among them, the pull-out resistance test shall mainly be carried out, and the grouting density test can be added for important works. If the pull-out resistance does not meet the design requirements, it can be reinforced by using more anchor rods. That's all for this lesson. During the construction of anchor rods, to ensure the construction quality of the anchor rods, the following precautions shall also be paid attention to. First of all, before anchor rod installation, the slurry and water in the hole must be purged with a high-pressure air duct to ensure the bonding between the anchor rod and surrounding rocks. Secondly, grouting is the second operating point during anchor rod construction. During the construction of this procedure, grouting must be full. Finally, the base plate shall be perpendicular to the axis of the anchor rod during installation to play the maximum role of the anchor rod. That's all.